In a stunning announcement, the US revealed a groundbreaking hypersonic jet fighter developed with Elon Musk's genius touch. A machine so fast, so stealthy, it can outrun missiles and vanish from radar. This isn't just a jet. It's a weapon that could change the balance of power on the global stage. With the speed to strike anywhere in the world within minutes, it's a nightmare for adversaries and a triumph for modern technology. Elon Musk's role in shaping modern warfare. Musk is playing a huge role in reshaping how modern warfare looks, and it's nothing short of groundbreaking. What makes him unique is his ability to apply his futuristic ideas and tech expertise to areas that were once strictly the government's turf. Now, with SpaceX and other projects under his belt, Musk has become a key player in US military advancements. One of the most significant ways Musk is contributing is through CRADA, which stands for Cooperative Research and Development Agreement. Think of it as a handshake between private companies and the government to share tech and knowledge. Through this agreement, Musk's SpaceX has teamed up with the Pentagon, working on projects that are vital to national security. But it's not just about sharing blueprints. It's about creating innovative solutions that the military desperately needs to stay ahead. Take, for instance, the $149 million contract SpaceX secured to develop missile tracking satellites. This wasn't just any contract. It was a game changer. These satellites aren't just floating around in space. They're designed to detect missile launches in real time, offering critical intelligence to the US military and its allies, including Ukraine. Imagine the advantage of knowing where and when a missile is coming. It's like having eyes everywhere. And Musk's technology made it possible. This project laid the foundation for what's happening now with the hypersonic jet. Musk's innovative management style is another reason he's so successful in the military arena. Unlike traditional aerospace companies that can take decades to develop a new aircraft or weapon, Musk pushes for rapid prototyping and aggressive timelines. His motto seems to be, fail fast, learn faster. This approach has been a breath of fresh air for the Pentagon, which often struggles with slow, bureaucratic processes. Musk doesn't just build, he reinvents how things are built. A perfect example is the way SpaceX developed the Starship Super Heavy rocket system. Originally designed for interplanetary travel, it's now being adapted for military purposes, like ultra-fast cargo transportation. The US military even placed an order for a spacecraft capable of delivering 80 tons of cargo anywhere in the world within just 60 minutes. That's mind-blowing when you think about it. The current standard transport plane, the C-17 Globemaster, takes 15 hours for a similar mission. Musk isn't just innovating, he's compressing time itself. His role in the hypersonic jet project follows the same playbook. Musk isn't afraid to take risks, and his focus on cost-effective solutions, like using stainless steel for heat-resistant components instead of exotic materials, means the military can develop cutting-edge technology without breaking the bank. He's not just creating new tools, he's changing how we think about building and deploying them. This partnership between Musk and the US military feels like a glimpse into the future, where private companies and government agencies work hand in hand to achieve what was once thought impossible. What makes this jet a nightmare for adversaries? This isn't just another fighter jet. It's a technological marvel designed to dominate the skies in ways we've only dreamed about. So what makes this jet such a nightmare for adversaries? Well, buckle up, because it's all about speed, stealth, and versatility. To put that into perspective, the SR-71 Blackbird, which was considered the gold standard for fast jets, maxed out at just over Mach 3. This new hypersonic jet makes that look slow. At such speeds, the jet can outrun almost any missile fired at it. By the time an enemy radar system detects it, the jet is already gone, like a ghost. That's what makes it so terrifying for anyone on the wrong side of its mission. But speed alone doesn't win wars. Which brings us to stealth. This jet isn't just fast. It's designed to be nearly invisible to radar. Remember the SR-71 Blackbird? It was known as the ghost in the sky because of its stealth capabilities. And this hypersonic jet takes that legacy to a whole new level. With advanced materials and innovative designs, it can fly undetected into enemy territory, gather intelligence, and return without anyone even knowing it was there. And then there's versatility. This isn't just a reconnaissance jet or a strike fighter. It's both. The hypersonic jet is being built to handle a range of missions, from spying on enemy movements to launching precision strikes on strategic targets. Imagine a jet that can spot a target, relay the coordinates to Allied forces, and then launch a hypersonic missile to eliminate the threat, all in a matter of minutes. That's the level of versatility we're talking about. What's even more impressive is how this jet integrates with other advanced technologies, like hypersonic missiles. Russia has been flaunting its Kinzhal missile, which can reach speeds 10 times the speed of sound. The U.S. hypersonic jet is designed to counter that threat, and then some. By acting as a launch platform for its own hypersonic missiles, the jet can strike from thousands of kilometers away, making it almost untouchable. If you're wondering how this jet stacks up against other cutting-edge projects, let's look at the Lockheed Martin SR-72, often called the son of Blackbird. This jet has been shrouded in secrecy for years, but it's rumored to reach speeds of Mach 6 or more. The new hypersonic jet draws heavily from the SR-72's advancements, but pushes the boundaries even further. With Elon Musk's involvement, it's likely to incorporate innovations like unmanned flight capabilities, making it even more lethal and efficient. One of the most terrifying aspects for adversaries is the jet's ability to disrupt modern air defense systems. Traditional anti-aircraft weapons rely on predicting a jet's trajectory, but when you're dealing with hypersonic speeds, there's no time to react. This jet could fly over heavily fortified areas, gather critical intelligence, and leave without giving air defense systems a chance to lock on. It's not just a fighter jet, it's a game changer. The tech that makes it fly, propulsion and beyond. When you think about a jet that can fly at hypersonic speeds, you can't help but wonder, what kind of engine powers something like that? The answer is as fascinating as it is groundbreaking. The turbine-based combined cycle, TBCC, propulsion system. This marvel of engineering isn't just a step forward, it's a leap into the future of aviation. So, what exactly is the TBCC propulsion system? Think of it as two engines in one, working together seamlessly. First, there's the traditional turbine jet engine, which is what most fighter jets use. It's reliable and great for lower speeds, getting the jet off the ground and accelerating up to supersonic speeds. But once the jet hits a certain speed, around Mach 3, this engine hands off the job to the scramjet, short for supersonic combustion ramjet. That's where the magic happens. The scramjet doesn't rely on traditional moving parts like a turbine. Instead, it uses the jet's own speed to compress incoming air, mixing it with fuel and igniting it to produce thrust. This allows the jet to reach hypersonic speeds of Mach 5 or more. The beauty of the TBCC system lies in its ability to transition between these two modes. It's like a car that can seamlessly switch from gas to electric power, but at thousands of miles per hour. This combination of technologies lets the hypersonic jet operate efficiently across a wide range of speeds, from takeoff to cruising at Mach 5+. Of course, reaching these speeds isn't just about having the right engine. Hypersonic travel comes with its own set of challenges, and they're not for the faint of heart. One of the biggest issues is extreme heat. At Mach 5 and beyond, air friction generates so much heat that the jet's surface can reach temperatures of over 1,800 degrees Fahrenheit. That's hot enough to melt most conventional materials. On top of that, the high speeds create a layer of plasma around the jet, which can interfere with communication systems and make it harder for the aircraft to stay under control. Then there's the issue of material durability. At these temperatures and pressures, even the strongest alloys can start to break down. Traditional aviation materials just don't cut it. This is where Elon Musk's innovative thinking comes into play. Instead of using exotic and expensive materials, Musk's team at SpaceX developed a cost-effective solution using stainless steel. Stainless steel might not sound high-tech, but it's incredibly durable, heat-resistant, and most importantly cheap compared to alternatives. Musk even used this approach in the development of SpaceX's Starship, proving that sometimes simplicity is the ultimate sophistication. To handle the extreme heat, Musk's team designed a clever cooling system. Instead of relying on complex and costly materials, they used simple engineering principles to circulate fuel through the jet's surface areas, absorbing and dissipating heat before it could cause damage. This approach not only keeps costs down, but also ensures the jet can handle long-duration flights at hypersonic speeds. All of this technology comes together to make the hypersonic jet a true marvel of modern engineering. It's not just about going fast. It's about doing so safely, reliably, and affordably. The TBCC propulsion system and Musk's innovative materials and cooling solutions are what make this jet possible, and they represent a new era in aviation where cutting-edge technology meets practical, real-world application. A glimpse at the SR-72 and its role. If you've ever been fascinated by military aviation, you've probably heard whispers about the SR-72, a jet so advanced it's been dubbed the son of Blackbird. But what makes the SR-72 so special? Let's dive into the mystery surrounding this hypersonic marvel and why it's considered a potential game-changer for the U.S. Air Force. First, a little history. The SR-72 is often seen as the successor to the legendary SR-71 Blackbird, a reconnaissance jet that first flew in the 1960s. The SR-71 was a beast. It could cruise at Mach 3 and fly so high and fast that no missile of its time could catch it. It was essentially a ghost in the sky, gathering intelligence and evading enemy defenses with ease. The SR-71 set the bar for what a reconnaissance aircraft could be, but the SR-72 is poised to take things to a whole new level. Rumors about the SR-72 first started swirling in 2007, and they've only grown since then. It's said to be capable of speeds over Mach 6, twice as fast as its predecessor. At that speed, it could cross the entire United States in under an hour. And it's not just about speed. The SR-72 is rumored to have advanced stealth capabilities, making it nearly impossible to detect on radar. Imagine an aircraft that can fly faster than any missile, gather intelligence, and leave enemy defenses scrambling, all before they even know it's there. What's fascinating about the SR-72 is how it's designed for versatility. Unlike the SR-71, which was primarily a reconnaissance jet, the SR-72 is said to be capable of precision strikes. Picture this. The jet flies into enemy territory, identifies high-value targets, and launches hypersonic missiles to eliminate them, all in a matter of minutes. It's not just a spy plane, it's a weapon in its own right. Of course, all of this sounds almost too good to be true, and that's part of the mystery. The U.S. Air Force has been tight-lipped about the SR-72, neither fully confirming nor denying its existence. The few details we have come from cryptic statements and conceptual images, leaving aviation enthusiasts and military analysts to speculate. Is the SR-72 already flying in secret? Or is it still on the drawing board? We may not know for sure, but the potential is enough to keep everyone guessing. When you compare the SR-72 to the SR-71, the differences are striking. The SR-71 was an icon of its time, but it relied on 1960s technology. Its titanium body was built to withstand the intense heat of Mach 3 flight, and its cameras and sensors were cutting edge for their era. The SR-72, on the other hand, is designed to operate in a world of hypersonic missiles, AI, and advanced air defenses. It's like comparing a classic muscle car to a modern electric supercar. They're both impressive, but one is clearly built for the challenges of today. The SR-72's role as a strategic trump card can't be overstated. In a world where speed, stealth, and precision are more important than ever, this jet represents a new frontier in military aviation. Whether it's outpacing enemy defenses, gathering critical intelligence, or delivering devastating strikes, the SR-72 could redefine what's possible in the skies. Why hypersonic jets matter in modern warfare. These aren't just faster planes. They're a revolution in military strategy, and they're changing the way wars are fought. Imagine a weapon that can cross continents in minutes, outpace the most advanced defenses, and deliver devastating strikes before the enemy even knows what hit them. That's the promise of hypersonic technology, and it's why countries like the United States are racing to perfect it. One of the most exciting aspects of hypersonic jets is their potential for ultra-fast transportation. Take SpaceX, for example. Elon Musk's company has been working with the U.S. military to develop a spacecraft capable of delivering 80 tons of cargo anywhere in the world in under 60 minutes. Think about that for a second. The U.S. Air Force's C-17 Globemaster transport plane, which is the current standard, takes 15 hours to complete a similar mission. Hypersonic jets would shrink that time frame to an hour, opening up entirely new possibilities for military logistics. Hypersonic jets aren't just about moving cargo. They're about redefining combat itself. Take the ongoing situation in Ukraine as an example. Russia has been showcasing its hypersonic missile technology, like the Kinzhal missile, which can travel at speeds 10 times the speed of sound. This weapon can hit targets over 1,000 miles away with precision and is capable of carrying nuclear or conventional warheads. It's a terrifying prospect, and it's forced the U.S. and its allies to rethink their defense strategies. Enter the hypersonic jet. Unlike missiles, which are designed for one-way trips, jets have the versatility to perform multiple missions. They can conduct reconnaissance, deliver payloads, and even act as a launch platform for hypersonic missiles. Imagine a U.S. hypersonic jet flying over contested airspace, gathering intelligence, and launching precision strikes on enemy missile launchers before they can pose a threat. It's a game of cat and mouse. But at hypersonic speeds, the jet is the cat that can't be caught. The Ukraine conflict highlights just how important speed and precision have become in modern warfare. Traditional air defenses are built to track and intercept slower-moving targets, like cruise missiles or fighter jets. But hypersonic jets change the rules. Their extreme speed makes them almost impossible to track, let alone intercept. This means they can operate in heavily contested areas with minimal risk, giving the U.S. and its allies a significant strategic advantage. But it's not just about speed. It's about strategy. Hypersonic jets can quickly deliver critical supplies or reinforcements to troops on the ground, even in remote or hostile environments. They can also provide real-time intelligence, helping commanders make faster, more informed decisions. In a conflict like Ukraine, where every second counts, this kind of capability could be the difference between success and failure. And let's not forget the psychological impact. The mere existence of hypersonic jets is a deterrent. Knowing that your adversary can strike anywhere in the world within minutes changes how you approach a conflict. It forces you to rethink your defenses, your strategies, and your expectations. In this way, hypersonic jets aren't just weapons. They're tools of influence and power projection. In short, hypersonic jets matter because they represent a fundamental shift in how wars are fought. They combine speed, precision, and versatility in a way that no other technology can match. Whether it's countering threats like Russia's Kinzhal missiles, delivering supplies to troops, or reshaping the strategic landscape, these jets are more than just machines. They're the future of warfare, the road ahead, challenges, and innovations. As exciting as hypersonic jets are, they're not without their challenges. Developing a plane that can travel at 5 times the speed of sound or faster is no small feat. There are still significant hurdles to overcome, but the good news is that engineers and scientists are making incredible progress. One of the toughest problems with hypersonic jets is dealing with extreme temperatures. When a plane travels at hypersonic speeds, the air friction generates enormous heat, enough to melt most materials. At Mach 5 and above, the surface of the jet can reach temperatures of over 1,800 degrees Fahrenheit. That's hotter than the temperature required to bake a pizza in a wood-fired oven, and it's a constant threat to the jet's structure. Traditional aircraft materials just don't cut it in these conditions. That's where advanced materials come into play. Engineers are exploring everything from heat-resistant alloys to ceramics and composite materials. One of the most promising approaches comes from SpaceX, where Elon Musk's team has been using stainless steel for its Starship spacecraft. Stainless steel might sound old-fashioned, but it's incredibly durable, cost-effective, and capable of withstanding high temperatures. Combined with innovative cooling systems that circulate fuel to absorb and dissipate heat, this material could be a game-changer for hypersonic jets. Another challenge is ensuring agility and maneuverability at such extreme speeds. At hypersonic velocities, even the smallest adjustments to the aircraft's trajectory require immense precision. Traditional control surfaces, like flaps and rudders, struggle to perform effectively at these speeds. Engineers are experimenting with new control technologies, such as using plasma or shock waves to steer the aircraft. It's cutting-edge stuff, and it's pushing the boundaries of what's possible in aerodynamics. Then, there's the issue of human endurance. At hypersonic speeds, the forces acting on the pilot can be overwhelming. The acceleration alone creates intense G-forces that can strain the human body to its limits. To address this, many hypersonic jet designs include options for unmanned operation. By removing the need for a human pilot, these jets can take on missions that would be too dangerous or physically demanding for a person. Imagine a hypersonic jet flying deep into enemy territory, gathering intelligence, and returning safely, all without risking a single life. Unmanned technology also opens the door to new possibilities. Without a pilot, the jet can be lighter, faster, and more versatile. It can perform longer missions, operate in more hostile environments, and take risks that would be unthinkable with a human on board. This shift toward autonomous systems is part of a larger trend in modern warfare, where AI and robotics are becoming increasingly important. Of course, there's still work to be done. Developing these advanced technologies requires massive investments in research and development. It also requires collaboration between government agencies, private companies, and international partners. But the potential rewards are worth it. Hypersonic jets have the power to reshape military strategy, deter adversaries, and protect national security in ways we're only beginning to understand. A game-changing partnership, public and private collaboration. The way military technology is being developed is changing, and a big part of that is thanks to private companies stepping into the arena. In the past, defense technology was almost exclusively a government affair. Think giant agencies like the Pentagon and DARPA running the show. But now, private players like SpaceX, Blue Origin, and Virgin Galactic are not just helping out. They're driving some of the most groundbreaking advancements we've ever seen. Elon Musk's company has been a trailblazer, showing what private innovation can bring to the table. From reusable rockets to satellite-based internet, SpaceX has disrupted industries that were once stagnant. But the collaboration with the U.S. military takes things to a whole new level through agreements like CRADA, Cooperative Research and Development Agreement. SpaceX isn't just supplying technology, it's reshaping how the military operates. For instance, the Pentagon's $149 million contract with SpaceX for missile tracking satellites was more than a simple transaction. It was a partnership, leveraging SpaceX's expertise to create systems that enhance not just U.S. defense, but also allied capabilities, like supporting Ukraine during the ongoing conflict. This partnership model is a win-win. For the military, it means faster development cycles and access to cutting-edge technologies. For private companies, it means financial support and the chance to tackle challenges that push the boundaries of what's possible. The Hypersonic Jet project is a perfect example. The military brings its expertise in strategy and warfare, while SpaceX brings its ability to innovate quickly and efficiently. The result? A jet that could redefine air combat. And it's not just SpaceX. Blue Origin, Jeff Bezos's brainchild, is also stepping into the military space. While it's better known for its space tourism ambitions, Blue Origin's heavy-lift rockets and advanced propulsion systems have significant potential for military applications. Imagine using their rockets for rapid deployment of satellites, or even hypersonic weapons. Virgin Galactic, led by Richard Branson, is another player to watch. While they focus on commercial space travel, their technology could be adapted for ultra-fast transport or reconnaissance missions. These companies are showing that private innovation isn't limited to commercial markets. It has real, game-changing potential for defense. This public-private collaboration signals a major shift in how defense strategies are evolving. It's no longer just about building weapons and planes. It's about integrating advanced technologies like AI, autonomous systems, and satellite networks into a cohesive strategy. Private companies excel at innovation and efficiency, while governments excel at strategic planning and large-scale operations. Together, they're a force to be reckoned with. What's fascinating is how this partnership is breaking down traditional barriers. Private companies are no longer just contractors. They're partners shaping the future of warfare. This trend is likely to grow, especially as new challenges emerge. Cybersecurity, space warfare, and AI-driven combat are all areas where private companies are already leading the way. The collaboration isn't just about technology. It's about building a defense ecosystem that's faster, smarter, and more adaptive than ever before. This new dynamic also raises interesting questions. How much influence should private companies have in military decision-making? What happens when commercial interests collide with national security? These are debates we'll likely see more of in the years to come. But one thing is clear. The partnership between public and private sectors is here to stay, and it's transforming how we think about defense in the modern era. What this means for the future of warfare. The introduction of hypersonic jets and similar technologies isn't just a technological leap. It's a seismic shift in global military power dynamics. Think about it. Speed, stealth, and precision at levels we've never seen before. It's the kind of advancement that could tilt the scales in any conflict, reshaping how nations prepare for and conduct warfare. Hypersonic jets are designed to travel at speeds exceeding Mach 5, which means they can cross entire continents in minutes. This changes everything about how military operations are planned. Imagine a world where a critical target can be hit halfway across the globe in under an hour. Traditional defenses like anti-aircraft systems and surface-to-air missiles become almost obsolete because they simply can't keep up. Hypersonic jets don't just outmaneuver, they outpace. But speed is just one part of the equation. These jets are also highly versatile. They can perform reconnaissance, deliver precision strikes, and even act as launch platforms for hypersonic missiles. This makes them invaluable in conflicts where adaptability is key. Take the ongoing situation in Ukraine, for instance. Russia's hypersonic missile systems, like the Kinzhal, have already demonstrated the devastating potential of this technology. A hypersonic jet not only counters those threats, but also provides the capability to strike back quickly and decisively. It's a deterrent and a weapon rolled into one. Now, let's talk about the future. One of the most exciting possibilities is the integration of AI and autonomous systems. Imagine a hypersonic jet that doesn't just follow orders but analyzes data in real time, making decisions faster than any human pilot ever could. AI could handle everything from navigation to targeting, ensuring maximum efficiency and accuracy. Autonomous systems would also allow these jets to perform dangerous missions without risking human lives. For example, a hypersonic jet could penetrate heavily defended airspace, gather critical intelligence, and return safely, all without a pilot on board. This raises an interesting question. Could these advancements replace human pilots entirely? On the one hand, removing the human element eliminates risks like G-force limitations and fatigue. On the other hand, there's something to be said for human intuition and decision-making, especially in high-stakes situations. It's likely we'll see a mix of manned and unmanned systems, with AI taking on more responsibilities as the technology matures. The ripple effects of hypersonic jets go beyond the battlefield. They change the way nations project power. In the past, a country's military strength was measured by the size of its army or navy. Now, it's about technological superiority. Countries that master hypersonic and AI-driven technologies will have a significant edge, forcing others to either catch up or risk falling behind. This could lead to new alliances as nations pool resources to develop and share these advanced systems. It could also spark an arms race as rival powers rush to match or surpass each other's capabilities. The introduction of hypersonic jets also raises ethical and strategic questions. How do we regulate weapons that are virtually unstoppable? What safeguards need to be in place to prevent accidental escalations? And how do we ensure these technologies are used responsibly? These are issues that governments, militaries, and international organizations will need to address as hypersonic technology becomes more widespread. So, what are your thoughts on this? Let us know in the comments below.